Hello and welcome to yet another video. And today we have an AM4 board. We have a Prime B450 MK2. I think I've fixed one of these before, not too sure what the problem was with this. And I'm not really sure what this one has. So the box already says it's Ryzen 3000 and 5000 ready, so interesting. It must have been sold a little bit later. We got the AO shield, got the H shield mainboard itself. Let's get it out and have a look at what we have. So the box was able to fool me pretty well. This is an MSI A320M A Pro. So this isn't the Asus Prime. Interesting. Is this the fitting? Yeah, it is the fitting IO shield. So, yeah, pretty low-end board. Let's see what will be wrong with this one. So let's just get a processor into here and some power and see how this board behaves. We will be using our 2000G. Should be still supported by this. So let's see. Passive power consumption. That is very high power consumption. There is something majorly shorted with this. That was 200 milliamps of power consumption on a board that has no LEDs, nothing like that. So we will have to get our thermal camera out now. I hope this doesn't have like the 5VSB shorted into like every USB controller and all of that. So, oh, that is burning hot. Let's see. It was burning hot right there in that spot. Let's get the microscope out and see closer there. So, this component is burned through very well. JS7133RJJ05AKWK. No idea what that is supposed to be. What could this be related for? Actually, I have no idea, to be honest. So this is a MOSFET, I think. This Nikos one. But no idea what this is. Interesting. Well, let's get rid of it first. And that resistor we might also have to check. That might have burned up or any of these. But it looks like there's two big power rails coming into here. Like you can see that this pin has a big rail connected to it. And that goes all the way down here. Down here. Where is it going? This is the big trace. Interesting. So it definitely has to do something with the Enameld board just because it was getting hot already. And then there's this big trace as well. Is this VPP? It might be VPPM. Interesting. Yeah, but it's definitely burned through. So let's get rid of it first. Let's put some solder onto it, onto both sides, some leaded solder that the melting point is being lowered. And then we will go into Boardview and see what this is responsible for. The board might even work without that. We might also want to check that. So I will be desoldering this from the underside because there's a SATA connector very close to it. So I will be doing this off camera because I cannot get the board close to the edge of my table and also have my microscope pointing at it. So I will be holding it off the edge of my table and will be desoldering it by hot air. So we got it successfully removed, and I've moved that resistor from its place. Let's just quickly move that resistor back into its place, that I don't lose that. So now I'm cleaning up the area. So after cleaning up the area, I'm pretty sure that this resistor right here is also burned. Like that is a hole in that resistor. And we will definitely have to replace that as well. But let's for now see how this board will react. I want to check if that capacitor has a short circuit. So let's check that and also check the resistance of that resistor. So let's see. 0 ohms. Huh. That's not what I expected. I expected really high resistance right here, to be honest. 10 ohms. Interesting. Let's see here. This resistance is high. And let's see here. Also no short circuit. Okay. So we will definitely have to look at this resistor right here. This capacitor also fine. Okay. So let's go into let's just try to turn this board on and see what happens, how this board reacts not having this chip in here. So let's see for the passive power consumption now. We have 35 milliamps. This looks fine now, and now it's 0. Why is it 0? 0 is not nice. There might be some standby power rail missing. We will have to check that. Let's get our PCIe tester and see for the 3VSB if that is present. And our 3VSB is not present, as you can see here. So that probably means that whatever we remove, that regulator was for 3VSB. So there will also be no reaction to the power button, as we can see. Me trying to press the power button, but nothing happening. Let's check if our battery has also been drained. No, our battery is good. Okay, interesting. Okay, let's go into a board view then and check out what that is responsible for. Probably the 3VSB, might be the 5-volt dual, I'm not too sure, or some 5 volts standby. We need to find out what kind of what the part number of the MSI intern is, because we have the A320M A Pro, but MSI doesn't use that internally. They use a MS version, so they have MS and then some combination of numbers and letters, and there's also the revision number close to that, and it most of the time is close to where actually the name of the board is, but I can't find it right now. So let me quickly find out where it's written on this one. There it is. MS7C51 version 1.1. That is what we need. So let's have a look now at what was burned up. So we need to go down here, and this is probably our output. Yeah, it is the 5-volt dual that has died on our board, and this is the output. Oh no, this is the 3VSB phase. It was the different direction. I thought it was going from top to bottom, but it's going from bottom to top. So this is the input, pin 3, which is 5-volt dual. And then we have 3-volt enable right here. 3-volt VSB control. We have 3VSB here. And the 3VSB feedback. So let's check if any of these outputs are shorted. Let's check the 5-volt dual and the 3VSB in order to see if that is still working or not, or like if there's a reason why that's shorted, why this one below. So let's check right here. So we are in ohms range. I got a ground, and let's see. The 5-volt dual is this lower one right there, and that has higher resistance. Let's go in a higher range. Even has higher than 20k. Interesting. Let's go to 200k then. Okay, this seems to have very high resistance. Okay. Well, let's check the 3VSB. And the 3VSB has kilo ohms, which is very nice, which is what we want to see. So I don't think I have that component on hand. So we will be trying something different. Let's see what happens if we supply the 3VSB ourselves. Because I don't think there's a power good signal that needs to be going out. But let's inject that ourselves and see if the board can turn on then. If that is all of the problems we had with this board. So if we turn it on right now, we have basically 0 for the power consumption. I now have 3.3 volts on our power supply. And I will be injecting it now into our 3VSB. And it now turned on our PCIe tester. And you can also see power consumption, 50 milliamps, which looks very nice. And I will need a power button first now. So let's see. And it turns on. 2.2 amps, that looks very nice. Taking it off, it instantly turns off. Let's get something that I can get an indication if this is posting or not. So we will be connecting a speaker onto here. So I now have a speaker connected to here also. And I've also got the post screen onto here. Let's get the CPU fan into here. And let's see now. Let's see. Do we get a post beep and do we get a post screen? And there's the post screen. No beeps though. Interesting. So let me hit the power button to turn it off. And now it turned off. And that is all we... And yeah, that seems to work. So we really only have that 3VSB regulator that was blown. We will have to look for that resistor though. Because that resistor was way too low. That resistor looked really blown. So let's go into the board view once more and see what kind of value that is supposed to have. So let's see. This resistor is supposed to be a 10 ohm resistor. And that resistor is actually reading 10 ohms. Wow. It looks so burnt. It looks so dead. Interesting, but it checks out. Let's see what this controller is. Because I have no idea. GS71137133SO. Let's check that. So let's see, this is a maximum 3 amp low dropout voltage regulator. This even has a power OK output function. Interesting. So let's see what is used on our board. Let's see. The first pin is not connected. The second one is an enable signal. So the enable is still there, okay? The first one is power OK. So the power OK signal is not being used, which is good. Let's see what else is used. So we have the 5-volt dual that is coming in. This is just the supply voltage. We have 3VSB control. Let's see what that is. So 3 is VIN, 4 is VDD. What is VDD responsible here? VDD supply voltage for control circuit. A 3 volts or 5 volts supply voltage for control circuit is recommended, and supply voltage should be 1.5 volts higher than the output voltage. Interesting. What is it connected to? 3VSB control. Is this just pulled to... Yeah, this is just pulled to 5VSB. So there's just 5VSB going on to here. There is nothing more here. Okay. So let's see. 5 is not connected. What is 5? So 5 is not connected. Okay. 6 is the V out, which is just our 3VSB. 7 is feedback. There, yeah, that is for having the voltage linearly. So with a adjusting load that it's still close to 3.3, and then there's just ground. Okay. I will try to find this exact controller if I have it on some donor board, maybe. If not, we will be trying a linear regulator in here. So let me first look if I can find this actual controller, the GS7133. So I found this, which is a MSI Z170A PC mate that has a dead socket that is a donor board for me. And let's look at the microscope what I've found. And if you have a look at this, it's a GS7133. So we will desoldering that and we'll be putting it on our board. So we now have put it here, and I will be soldering on from the bottom again to solder it on. And I need to apply some flux and also let it solder to that ground pad so it's easier to solder on. So let me quickly do that. So the controller is on. And let's clean up the area. So I hope the orientation is right. And let's now plug it in and see if it works now. And now let's have a look. 160, that doesn't look good. That is too much. Is the controller getting hot? I'm very worried here. Let's see if the 3VSB is present. But the 3VSB is just present. Weird, that's kind of much. Let's check again that resistor, because I don't like that. So this resistor right here is supposed to be the VDD connected to 5VSB. That is 10 ohms, and it is 10 ohms. I want to see with the thermal camera if anything is heating up in that area, because I do not trust that amount of power consumption. So let's see now. But there's nothing getting hot here. So there's only the 3VSB regulator getting like 38 degrees, but that's nothing. So I'm not sure why that power consumption is so high, but I just cannot see anything that is getting hot. There is the Ethernet controller, I think, but that's also just 32 degrees. That's probably nothing. So definitely you have to do some checks as soon as this board is in Windows to make sure that everything is working. Like for example the Ethernet. I will be plugging in a GPU also into here. Let's put a different processor also into here, so we don't have an APU but a normal CPU in here. So let's see, there's a 3100 in here now, and let's put a GPU also into here. So everything is connected. Let's now see how this reacts. And I will be also monitoring a little bit with my thermal camera because of the little bit higher power consumption. But I don't think there will be anything wrong with it, because like 2.2 amps looks really fine. So the board is now working. It is now fully up and running. The Ethernet is working, and also the sound is working. And yeah, I'm just not too sure why we have that high power consumption in standby. Like 150 milliamps is a little bit high for what I have seen in other boards. So for my experience, 150 milliamps is a little bit high for passive power consumption. I've now shut the board down, and let's see, and it is at 120, which is better, but still kind of weird. But nothing is really heating up, and yeah, it seems to be working just fine now. And I've never had that actually. I never had the 3VSB regulator actually fail in that way, where it actually had a hole in that. And yet again, the amp meter shows how important it is and how good of information it gives you just from the get-go, just from 5VSB. I instantly saw that there was something wrong with the 5VSB drawing way too much power, and it helped us to figure out the problem very quickly with also using the thermal camera. And yeah, hope you learned something, hope you enjoyed this repair. Thank you very much for watching. This was Mainboard Medic. All of my tools are linked in the video description. Thank you very much, and goodbye.